Well, good afternoon, everyone. For those I haven't met, I'm Eric Nordberg. I work in the library here on campus, and we're very happy to co-host this series, the UT Martin Research Series, with the Provost's Office, Vice Chancellor for Academic Affairs. My usual spiel is to remind people that a lot of folks think of UT Martin as a teaching school, and we do a lot of incredible teaching here, but it's also part of the program that all of our faculty undertake various types of research projects. And very often that work isn't always highlighted in the things that we do. So we developed this series to try to bring those things out. During this spring 2024 semester, we decided that we'd try to theme a series of 4 events that looked at women in STEM. So some of the activities that are going on campus. We have a newly formed Women in STEM student organization that's been kind of promoting bringing more women into the STEM fields across the country, and so this has been an important part of that. Last month we had a panel discussion with 7 students here at UT Martin who've been involved in various types of research across different disciplines. Today we're going to hear about a little bit of work with engineering. We've got another event coming up in April 11th. Violet Buma, who's one of our faculty in chemistry, will be talking about some research that she's been doing looking at the use of light therapy in medical applications. And then we'll actually finish up the series in May. We try to have one or more events that are off campus. So just after commencement on Thursday, May the 9th, we'll have another one of our faculty members, Lily Ferris, who's with our computer science department. She'll be giving a talk about cybersecurity. And we'll actually do that event down at the Martin Public Library that evening. So we try to outreach to the community. She's been doing research on cybersecurity, and we thought that would be a good one for our local audiences. I have to say that today's presentation is kind of special to me. I grew up in the Detroit area, and I actually worked my way through graduate school as a purchasing agent for a small shop in Detroit that made control systems. And so probably during the couple of years that I worked there, I literally purchased hundreds, if not thousands, of push buttons from Allen Bradley and other devices that we're going to hear our speaker talk about today. But this is, in addition to being a great program for our students, I think it's a real critical time for us here in West Tennessee in other ways. And with that in mind, I wanted to invite Alicia Melton, who's our Executive Director for Research and Sponsored Programs and also for Economic Development, to talk a little bit about one of the really big projects that's coming to West Tennessee and how that fed into this project. And she'll also talk about the principles that were involved in developing the grant that supported what you're going to hear about tonight. So with that, I'll turn things over to Alicia Melton.
Thank you, Eric. So I've gotten to know Ashley really well over the last year or so, because when Ford announced their new plant in Haywood County, Blue Oval City, we immediately formed a UTM Blue Oval response team. And so what we did is we pulled together from across the campus, just experts in every area, to think about how can we partner with Ford, how can we make sure that we are giving them the support that they need, and also thinking about the workforce development. I mean, these are going to be new skill sets that we're going to need for our communities, and how can we make sure that we're ready for the expansion that's going to happen. When this campus opens up, it's going to be about 6,000 direct jobs, and who knows how many indirect jobs, so we want to be ready for that. So the team members have worked with a lot of different people in the Ford organization. One of the first things we did was work with Nancy Bushhouse, who's the Dean of Engineering and Natural Sciences, and she helped us develop a plan for a grant proposal that involved Dr. Steve Elliott and Dr. Ashley Owens. And what it did is it funded mechatronics awareness workshops for K-12 educators at our regional centers in Ripley and Summerville, and it also funded a week-long introduction to mechatronics workshop for K-12 educators and principals last summer. And the importance of these is our area needs to know what advanced manufacturing is going to do for our area, and so having these 2 individuals go into the classroom and talk with these educators who can then share that with the children is very important. And I think that was one of the most special things that we did as part of this work on the response team. We've also hosted school superintendents, principals, and educators with Ford to talk about those skills that they need. We've conducted leadership training sessions for the Ford Motor Company at the Summerville Centers. We've submitted a few grants in partnership with Ford, and we hope those will be successful. And then Dr. Adnan Razul, with our College for Business and Global Affairs, has conducted an equitable needs assessment survey, and he's involved a lot of our business students in that, so we're really excited about that. So I'm excited that Ashley is here today, and she is a native of Martin and a graduate of South Fulton High School. She holds a bachelor's degree in engineering from UT Martin, as well as a master's degree in mechanical engineering and a PhD in industrial engineering and engineering management from the University of Tennessee State Institute in Tullahoma. She has worked as a design and facility engineer before returning to the classroom, and she currently teaches coursework in industrial robotics, polymer manufacturing, hydraulics, and pneumatics. And she also serves as a faculty advisor for the UT Martin Aero team, which invites teams of student engineers to compete in the design, presentation, and flight of self-constructed aircraft. And one of my favorite things about Ashley is just her genuine enthusiasm and love for her field, so it's always great to hear her talk.
I've got a mic here. I'm cheating. I'm wearing the lapel mic. All right. Can y'all hear me okay? Good? All right. Again, I'm Dr. Ashley Owens, as stated, 2005 graduate of UT Martin. I have been fortunate, once I got my master's, I was able to work within 30 minutes of here, so I've seen a lot of the manufacturing in the area. And you've got this big place called Blue Oval City coming in, and so they're starting to make a big push and drawing a lot of attention for the manufacturing and mechatronics needs in this area. As a side note, the yellow robot here, I actually learned to program on this exact robot when I was here in 2001 to 2005. So I had very familiar with that when I walked in. But over the summer, as Alicia said, we started working with Blue Oval City. They wanted to put on some workshops for local teachers, administrative folks that wanted to come in. And Dr. Elliott was nice enough to work with me. He runs the STEM Center. And we did a couple two-day workshops at the Somerville Center and the Ripley Center. We had close to 40 teachers total come to those two workshops. And they were what I call a crash course in what is mechatronics, what can you expect, and then those two-day workshops turned into a 5-day workshop that was held here at campus, where we dove in a little more in depth as to what is manufacturing, what is Blue Oval City, and not just Blue Oval City, what is Stanley Black & Decker down the road, what is Plastic Products, what is Parker Hannifin in Greenfield. If you just look around, there are a number of manufacturing facilities just in this area. What are they looking for? What do they want from students? What do they want from college students? What do they want from high school students coming out? Because college is not for everybody. And so they're trying to get people enthused. What is manufacturing? What all goes into it? What is mechatronics? And that question goes into, what is mechatronics? Well, it's mechanical engineering, electrical engineering, computer engineering, controls engineering, all thrown into a bag, shaken up, and then you get this nice, pretty system. And the best way to describe mechatronics is these are 4 stations that we purchased from Siemens. I actually went to Atlanta, Georgia to receive level 1 training on this equipment, and then I got sent to Germany for 2 weeks to get level 2 training on this mechatronics equipment. How this system works, you will see a variety of mechanical components, electrical components. You get into what is called a PLC, or a programmable logic controller, that basically uses inputs from various sensors that you will see on the carts. And then it sends an output and tells each station what to do. The only operator input that is needed is every so often I have to load the canisters, I have to load the lids, and I have to turn the key and hit the start button. The system does everything else on its own. It will take the canister, feed it to the conveyor. It will then check to see if it has a lid installed. If it doesn't have a lid, it takes it, installs a lid, and then the final station sorts it by color: red, silver, or black. And the workshops that we had here, we were able to demonstrate these units. And I will demonstrate that unit here shortly. One of the issues that we ran into for the 2-day workshops is we were going to purchase some of these. We were going to send some to Ripley, going to send some to Somerville because they're hard to transport. Electrical components, you don't want to pack them up. You don't want to put them in a truck, rattle them, shake them down, or send them down the road and have issues when you get there. So we got a quote. To give you an idea, this is about $100,000, $120,000 worth of equipment. So it's not cheap. And when we put in the order, they said, oh, by the way, it's 16 to 18 weeks before you're going to get your equipment. Our workshop was in a month, I think. So we were kind of in a bind. So on a smaller version, more simplistic, we developed, hang on. We developed a small trainer panel. And in this trainer panel, this would be a similar trainer panel to if they go work at Blue Oval City or Stanley Black & Decker or an operating facility where you've got a training panel, you've got status indicator lights, you've got a push button to operate, on this model, a control fan. It also has an e-stop. As you open the trainer panel, it has a miniature PLC. So this little PLC is a PLC just like on these larger stations, except for you can program this one on the screen. You don't have to hook in a computer. And as many of the teachers said as they walked in, that is very intimidating. They were slightly imitated by these trainer panels, but by the end of the 2-day workshops, they were exciting, wanting to put in orders, figure out what they had to order so that they could build these and work on these with their students. But it has a small PLC, a power converter, terminal strips, and as you can see, all the wires to create the system. Excuse me. And so at the 2-day workshops, what we did is we went in, and all the teachers had to do there were wire up the panels, and then we let them program the PLCs. They absolutely loved it. Like I said, they looked at these, we showed a video, they said, hey, that's kind of intimidating. They looked at these small panels and were like, hey, we can do that. Our kids would love these. And it's good introductory level. It gets them programming PLCs. Sorry. It gets them programming PLCs. It gets them reading schematics. It gets them using hand tools. It gets them working as a team. Now, one thing I didn't bring that we did in the workshop that I don't know if they loved it or hate it, but we had a pin assembly line. And Dr. Bushhouse in the back is laughing. She actually got to witness this too. It's a very simplistic thing. You take a pin that is 5 or 6 components. You put 4 or 5 people on a team and you let them assemble those pins. It gets very competitive very quick. But it was a good operation that they could take back and have their students get in the mindset of, I've got components, I have to put them together. How do I do it in a manner that I beat the team sitting next to me? How do I do it in a manner that I beat my last time? How do I do it in a manner that, oh, well, I've got red pins on this order, I've got red and green on this order, I got purple and black on this order, and so it got them into that manufacturing mindset. I think they liked it by the end of it. I think they kind of thought we were crazy when we first did it. I'm actually going to do it with one of my classes here. It actually builds good team building skills. We actually had a couple of the teachers say they were going to take it back and use it with their teachers. Because it was very evident when people worked together. It was very evident when you had too many chefs in the kitchen also. Okay? But as part of that workshop, they would go in, again, wire up these panels, but using a schematic. They had all the hand tools. And when the panel is completed, basically what you have happen, and you hit the start button. Now, you're not going to be able to hear this one. I've got another one over there you'll be able to hear. I press the start button. I get a green light. That tells the operator, hey, the system is in operation, and there is a cooling fan on the side of this that is now activated. If I happen to hit the e-stop, nothing happens. So it gets them familiar with working with the e-stop. If I hold down the start button, everything's working, somebody accidentally hits the e-stop, it kicks the system in default. So it gets the teachers familiar with indicator status, take that, talk to the kids about monitoring systems, what's going on in the system, what's wrong with the system. It would allow them to get them to start teaching troubleshooting skills. Disconnect wires, wiring. Matter of fact, we had one set of teachers, they actually wired it up incorrectly and were blowing the transformer every time. They were shorting it out. And what it was is they had just placed a wire wrong. It was a good troubleshooting exercise we went through with the teachers. And that was something that they're looking for with their students. The 5-day workshop that we had, they actually come in, they actually build the trainer panel from scratch. This trainer panel is completely disassembled. All the components are set in different bins. Their wires are set off to the side. The PLC is blanked out. They have nothing. And day 1, we start talking about the panel. Day 2, they start to construct it. Day 3, they wire it up. Day 4, they're programming. And then day 5, we get in and we let them play with the robots for a little bit. And I've got a demo on the robots as well. We won't leave them out. But the 5-day, they get more hands-on with the trainer panel. And the teachers that came here, they walked in, they said, this is very intimidating. But after working on this and building this, they looked at that and were like, okay, that's not as bad now. I kind of have a feel for what's going on. Because there was one other thing that I haven't talked about. You've got sensors located throughout here. On this trainer panel, you have a sensor over the fan. So notice as I hit the start button, and the fan is in operation, if I stick my hand in front of the sensor, it kicks the fan off. So it also gets the students and the teachers introduced to a very simplistic sensor. They can monitor the PLC. They can actually hook that PLC up to a computer as well if they want to monitor it. Then as they move into their high schools, if they want to purchase this larger equipment, you can actually get these with robotic arms. It'll make box erectors, so it'll make little cases to put your film canisters in. They get pretty fancy. But again, they can purchase these, and now it gives the students a chance to come in. They can program the PLC themselves. They can come in and modify each station. Teachers can come in and to troubleshoot. Actually, I had to troubleshoot this one today. The lid station was not picking up the lids and placing them on the components correctly. There's multiple things that you can do with each station to get people thinking about troubleshooting and how does their station work. What's the station supposed to do? Why is it not doing what it's supposed to be doing? And that was one thing that Ford and a lot of the other manufacturing facilities push is they want people to be able to troubleshoot. They want them to feel comfortable at their workstation, but then also be able to say, hey, this is not working correctly. I need to go find somebody and make it work correctly. And be able to, in a sense, explain what's going on. So if they were to purchase these for their high school, basically how these work, again, this is the only human command that has to be put in. I turn a key, and once I push the start button, it will push a canister out. It's going to send it to the secondary station. It's going to check, does it have a lid? Not. Okay, I'm going to put a lid on. And then it's going to sort it by color. And I should have grabbed a black one. I'm going to go ahead and throw a lid on that. Let's see if it works like it's supposed to. Because that one had a lid, notice this sensor activated an arm that says, hey, send this one to the back. It's already got a lid. It does not need to go to the lid installation station. Okay? Now, in a manufacturing facility, chances are you could have a robot continuously feeding parts, so an operator never has to be there. As the parts are sorted at the end, you could have another robot picking those parts up, placing them in a box. And so this gives them a good introduction of a whole mechatronic system in cart form. Another good thing about these carts, you can disassemble and you can work in 4 different stations. So you could have a group of students working, 3 or 4 students working on the first station, another group of students working on the second station, the third, and the fourth. Again, various sensors. This one is basically checking for the height of the canister. If it exceeds a set height limit, that's what engages the arm. So as I was talking about a PLC, I know some of y'all in here are familiar with PLC. Who has ever heard of PLC outside of this conversation? Okay. The best way I can describe a PLC, you turn on the stove, take your hand, stick it on the stove. What happens? Hopefully you pull your hand off. Okay. There is your thermocouple. Okay. You've stuck that on the stove. It senses a hot temperature. It sends it to your brain as an input. Your brain is the PLC. The brain says, oh, that's hot. I'm going to send an output, raise hand. That is how this PLC is basically functioning. It takes this sensor. It says, okay, that part's good. Do not send an output to that arm. If it measures that it has a lid, it sends an input, which then has an output that says, engage the arm, turn on the conveyor, send the part to the end of the conveyor. There is a fork sensor on the end that actually, on wavelength, detects whether it's red, black, or silver. If you want to really trick the kids, you can throw a clear part on there. It never picks it up from the initial stage. And that starts getting them to realize that, hey, now I have to have a special sensor to detect a translucent part. So this starts getting the students and even the teachers dealing with things that they're likely to see in manufacturing. A lot of these sensors that you're seeing here are going to be at Stanley Black & Decker. They're going to be at Ford Blue Oval City. They're just going to be in a different setup. They could be working alongside robots. I think Blue Oval City, what'd they say they're going to have 300 or 700 robots? I think it's 700. They're going to have 700 robots. That could include an AGV, which is an autonomous guided vehicle, which will actually carry truck frames and bodies around the shop. No operator. They're driving themselves around the shop. And then they will have a lot fancier robots than we have. But this was another part of the workshop that we did when the teachers came here, is we let them interact with the robots. And you'll see 2 different types of robots here. This one is called an articulating robot. It's one of the more common ones you'll see in a manufacturing environment. It is what is considered a 5-axis robot. This one is a new cobot. And the benefit to the cobot is it can work alongside you and I on the factory lines. They actually have them built in that if it bumps into you, it stops what it's doing. You get out of the way, you can restart it, and it can continue to work. This style robot in industry requires a large cage or light sensors. If you break that light sensor, you walk into the cage, that robot shuts down. It does not continue to work alongside you. I'll also show you a way their programming methods are different. This robot, I have to take the teach pendant. Every position that I want to move it, I have to use the teach pendant. I have to actually move that robot. Now, I'm not going to move it now because it's in the middle of a program that I'm going to let you see. But I'll show you here in a minute that if I want to move it, I can't sit here and take this robot and manually force it where I want to go. This robot, on the other hand, has a cool feature. I can come in. And I can grab and I can manipulate that robot however I want. and that is how I teach that robot. I literally grab it, move it, teach it, move it to the next spot, teach it, move it to the next spot. And they're actually good for certain welding applications. It has a path tool. I can grab it, put it in path mode, and if I want to draw a straight line, it is recording all along that line, and we'll go back and recreate that path. So if you've got a welder there, he can grab it, have his welding tip, he can follow the profile. For example, aluminum beds. Aluminum welding is a very challenging operation. You put a robot welder for aluminum welding, now you don't have to have an operator, and you're going to get the same weld every time. Now, I'm going to show you a couple demos with these. This one is going to do a palletizing demo. It's going to take 9 of these canisters, and it's going to place them in a formation here. This one is then going to come over, and I'm going to have it stack 4 of those canisters on top of each other. And then once the programs are done, I will go through and I will show you how you can manually manipulate this yellow robot, and if anybody wants to come operate them. I'll put it this way, when students come to visit, they come in this lab, I have them operate the robot before they leave. My aunt came a couple months ago. She told me, I'm not touching that thing. I was sending a video to the family because I had her running the robot. If you come on a tour with me, you are going to operate one of the robots. But again, this one, let me see, 2, 4, 6, 7. I think I stole 2. This one is going to go through, and it is going to perform a palletizing. So for instance, if you're in a manufacturing environment, maybe this robot's picking parts, placing them on the conveyor belt. This one then comes in, picks the container up, sets it on a pallet. So this one's going to palletize. That robot is running at full speed right now. And there you go. It has now taken 9 parts, put them on a pallet, and if this was in a mechatronic system, there could be a sensor that could tell it, hey, the pallet's full, signal a fork truck to come pick up the pallet, move the pallet out of the way. It would then tell the robot, hey, new pallet is cleared, now you can start restacking components. The big thing about a mechatronic system is you are using sensors, mechanical components, programming to communicate with each other, and perform operations. Ford Blue Oval City is going to be huge with this. Stanley Black & Decker right down the road. If you've never gone to see Stanley Black & Decker, that is a sight to see in itself. They're producing your Cub Cadet mowers that you're seeing. Parker Hannafin's, another good one down the road. Plastic Products. We've got a lot of manufacturing here. And so mechatronics is a big thing that a lot of the companies are getting into. And I'm going to shut that air off. And on reset. There we go. I hate air running. Okay. Now, if you want to see how this one is manipulated, So if I just want to take that arm and swing it around, I would actually have to be in. I have to take the panel. So just to show you, I cannot take that rope. Well, I mean, I can, but you don't really want to. Okay? There's a little freedom in there. But not like I can take that one and move it and manipulate. If I want to move this robot, then I basically have to go through, manually move that robot using a teach pendant. Okay? And so to teach that robot, I would have to take the pendant, move it to the location, teach the point, do the next operation, teach the point. And then also you are very limited with, you have to have robot cages, light sensors, or light curtains. They actually have them now where they have like 270-degree cameras that they can mount. But in talking with Stanley Black & Decker, they say, hey, those fail. It's a nasty environment where most of these are working. So a lot of them are still using your light curtains and your big cages. And so that's where the development of the cobot come in and says, hey, let's make a robot that can work alongside people. And we actually, when I worked for Plastic Products, one of our facilities in Iowa had a problem keeping employees. Their turnover rate was awful. People would come in, go to their first break, get in their car and leave. And so they bought a lot of cobots, and they would actually work on the line with the people. And so cobots are really making a name for themselves and coming around. But this one, I'm going to show you, is basically going to take 4 of these canisters, and it's just going to come in, and it's going to stack them one on top of the other. And let's speed her up. I don't know that I'm going to run this one at full speed because it even scares me running at full speed. So now I'll place another part. Let's speed it up a little. That is at 75% speed. There you go. And this was actually one of the projects that I had the kids do for this class. I actually gave them a competition. And the cobot, unfortunately, came in towards the end of the semester. I actually had a student who was able to take this robot and stack 12 of those canisters 12 high. And so I do want to run this. I'm not going to put any canisters. I do want to just show you if I run this full speed, how fast this robot will actually go. And so that is at full speed on the cobot. And we also like to let the teachers see the robots because when you hear a robot, oftentimes people think, oh, a robot's going to take my job. In all actuality, that's not the case. What that robot has done is opened up for the individual that was doing that job to now go do another job that was short-staffed. And the teachers and the students that we are dealing with, oftentimes they're going to be the one operating these robots. And so they need to be familiar with them and realize they're not that scary. They're actually, once you get familiar with them and operating, they're actually fun to deal with. And then to also let them know that robot is not taking your job. Somebody still has to be there to feel parts, feel components, troubleshoot the robot, operate the robot. But robots have their purpose. Can you move that fast and do the same job over and over and over and over and over and do it 24 hours a day, 7 days a week, 365 days out of the year? No, you're going to get tired. And so the robots, they are great for that. And so that way we can get the teachers in here. They can start to see these robots. They can get familiar with them. and they can start talking to their students about the robots. So that is pretty much everything that was covered within the workshops. If anybody wants to come up and operate the robots, I'll be happy to let you do it. I promise I'll crash that one out and show you you're not going to hurt anything. Matter of fact, I always show the kids the first day, here's what's going to happen. They're like, what if I crash it? I'm like, you're okay, I promise. Here's what's going to happen. It is going to fault itself out before it tears anything up. You will bag it out, and the robot will continue to work. So if you're afraid of tearing it up, you can ask my parents. They are sitting here. If it can be torn up, I would have already torn it up. Okay? I can tear up an anvil. I have not been able to tear these up yet. So, not that I have been trying, Dr. Bushhouse. But if they can be torn up, I would have torn them. So don't be afraid of them. Don't be scared. I'd be more than happy to give you the controllers and show you how to operate them. So, but that is basically the workshops and the mechatronics workshops. And we do have plans to do more over the summer. So I'm excited about those. It'll be another series of the 5-day. I think we've had talks of doing the 2-day. And so just trying to outreach and talk to as many teachers as we can. Yes? The 2-day workshops, we had anybody from junior high up to seniors in high school. We had some from Fayette Ware. We had them from Bolivar. I can't think of a lot of your Shelby, Lauder County, Dyer County. We even had a junior high teacher from Martin Westview come down to the Ripley Center. Now the 5-day workshop, we had Bolivar, we had Obion County, we had South Gibson, and we also had an individual that his wife ran the Jackson-Madison County school system, and he was voluntold he was coming to mechatronics training because he was going to run her program for her. He enjoyed it. He was a good one to have. He had a lot of industrial experience. That was one of the big questions we had at the workshop is, number one, how much is the equipment? And we actually had some schools, they were getting grants. And so they were looking at purchase or equipment to purchase. This right here alone cost us a little over $100,000 to purchase just these 4 stations. They range anywhere from $18,000 to $30,000. And these are, I started here in 18. So these are almost 6-year-old systems. The price has considerably gone up. I know I quoted them last year. So some stations are running you over $200,000 now. This trainer panel, that was another selling point. Parts, $1,700. Labor, you can build it in a couple days. So that was something that they liked. Now, does it offer the same thing these stations do? No. And trying to state that they do would be a big lie. But it is a good starting point. It is a good, because a lot of the schools around here don't have the funding. And if they can get the kids introduced with these, and then maybe they go to a TCAT or they come here to UT Martin, depending on what path. They then have a little bit of introduction. Now, if you want to see a setup, you need to go to Obion County High School. Their mechatronic station setup is amazing. And I have since learned they have knocked down a wall, and it's even bigger now. They have a station, I think they have 9 of these set up. They have the robotic arm. They've got various test stations along the wall. They were actually getting a second set of mechatronics stations. Fayette Ware also has another good one in talking with them. They've got a good setup down there. So, but believe it or not, we actually had an art teacher at the Somerville. And she came just to get ideas. So we did anybody from art major to, hey, I was told I was the CTE director and I know nothing about this and I am here to find out what do I need to teach. And some of the topics we talk about in the 5-day is lean manufacturing. What is it? Why is it important? Why is it important for you to show up to work on time? Why is it important for you to show up to work every day? And it's things that we all take for granted, but unfortunately in the workforce, go to your local restaurant. They've been short-staffed here lately. Go to Walmart. Go to a factory and imagine the turnover they're going to have. And so that's something the industry is wanting to get out there is, hey, it's important to show up. It's important to do your job. It's important to take pride in your job. And so we talked to him about that. We talked to him about lean manufacturing. I then go into not every type of sensor, because you know all too well where you work, there are hundreds, thousands of different types of sensors, but they get a good introductory course and do the different types of sensors. We talk about actuators, cylinders. So for example, here is an example of a cylinder. It extends to push the part out. It retracts to pull the part back and load a new one. Think about a tractor, a front end loader. That is a cylinder doing that operation. But again, so they get to learn about sensors, actuators. We talk about reading schematics, blueprints, because sometimes the people working on the line are going to have to be able to look at a schematic or a blueprint. So, good question. Are there any other ones? That's awesome. Yeah. What's that?
So you did this great project that touches on local schools. How does this then influence the work that you do here at UT Martin?
Well, I actually teach the industrial robotics course. So what I go in there is I'm training the students of, you may be the ones going out there and actually setting up these stations. We've actually got industrial controls courses. I know I've talked to Dr. Teague about the trainer panels. We've also got some other trainer stations set up back here. And so the students have access to these here. Because we, due to gracious grant money, we now have 11 of these trainer panels here on house that we can take to Somerville, Ripley, or anywhere that we would like to go, and then also use them in-house. So yes, some of that from the training. Matter of fact, I'm teaching a 490 course this semester, and that's the one I'm going to do the pen assembly line. Is I want to get the kids thinking about assembly and working as a team, and then we're going to talk about the lean manufacturing side of things, doing time studies. And those are all things that, as engineers, they may be leaving and going out into the workforce and doing. The workshops and then some of the things that I did coming from industry, I try to incorporate in all of my classes. I talk all day in class, and now I get here and I can't talk.
Great. Well, if there aren't any other questions, I know that Ashley would be only too happy to have you come up and work on a robot, but maybe we'll give her a round of applause for
Thank you.
What's the accuracy of how many times will this operate efficiently before maybe not?
The biggest issue we have, and a lot of it has to do, I think, with lighting, is this little sensor here. I was waiting for it to mess up because every time I put it on display, it messes up. So I tested it before I got here and it worked. If this sensor works, as long as parts are in there, it'll run as long as you ask it to. So now, in an actual industrial environment, it would probably have issues because what we're going to face is we would have a lot of vibration going on. And so some of the sensors would eventually get off with their measurements, or they may vibrate just enough that they're no longer in their original position. And that's things as engineers or as workers need to be aware of, hey, this sensor is not sensing what it's supposed to sense. I need to let somebody know. But here, I could keep reloading parts and it would run all day.